Hello learners. In the previous session of the course Environmental Impact Assessment for Environmental Health, you have learned about examples of noise impact assessment in construction worker, healthcare worker, mining industry, etc. Today in this session, I will give you an overview of energy auditing in environmental impact analysis. To start with, energy is one of the major inputs for the economic development of any country. In the case of the developing countries, the energy sector assumes a critical importance in a view of the ever-increasing energy needs requiring huge investment to meet them. India is the second most populous country, as we know, in the world, with a population of almost 1.3 billion and the third largest economy, which is measured by purchasing power parity, popularly called as PPP. India has seen strong economic performance in recent decades, enabling a significant decrease in poverty levels, greater energy access for its citizens, and growing penetration of cleaner energy across the economy. Having said this, India's sustained economic growth is placing an enormous demand on its energy resources, energy systems, and infrastructure. Over the past decades, energy demand has steadily increased across all sectors, whether it is agriculture, industry, commercial, residential, or any other sector, and it is expected to continue to grow. Speaking about major energy supply and demand trends, India's per capita energy consumption stand at 30% of the world's average per capita versus the global average of 1.29 TOE and the International Energy Agency average 2.9. India has 0.44 tons of oil equivalent, TOE, tons of oil equivalent. India's energy system is largely based on the use of coal for power generation, oil for transport and industry, and biomass for residential heating and cooking. Bioenergy and most coal supply are produced in the country, while oil and natural gas are mainly imported. If we see in 2017, India's total primary energy supply, that is TPES, was 882 million tons of oil equivalent MTOE, with nearly two-thirds, that is 554 MTOE, being covered by domestic production. Industry accounted for the largest share of India's total final consumption TFC, followed by the residential sector, transport and the service sector including agriculture. The Government of India has set ambitious renewable electricity target for the short to medium term. By 2022, according to GOI, the country aims to have 175 gigawatt of installed renewable electricity capacity. So, for reducing the consumption of energy, sustainable and energy efficient industrialization, timely energy audits are required. So, according to Indian Energy Conservation Act of 2001, it defines energy audit as the verification, monitoring and analysis of the use of energy and submission of technical report containing recommendation for improving energy efficiency with cost-benefit analysis and an action plan to reduce energy consumption. Energy audit is a powerful tool to accomplish appealing energy saving. In another word, energy audit is one of the most important tools for energy conservation and for achieving energy efficiency. Energy audit is the key to a systematic approach for decision making in the area of energy management. It attempts to balance the total energy input with its use and serves to identify all the energy streams in a facility. It quantifies energy uses according to its discrete function. Industrial energy audit is an effective tool in defining and pursuing comprehensive energy management program. In nutshell, energy accounting gives us an overall picture of energy availability and its use. Energy audit also help us in analyzing the data in a systematic and meaningful manner to evolve appropriate measure to introduce checks and balances in the system for reducing leakages and losses and achieve technical performance. In other words, we can say the energy audit would give a positive orientation to the energy cost reduction, preventing maintenance and quality control program which are vital for production and utility activities. Such an audit program will help to keep focus on variation which occur in the energy cost, availability and reliability of supply of energy, decide on appropriate energy mix, identify energy conservation technology, retrofit for energy conservation equipment, etc. In general, we can say that energy audit is the translation of conservation ideas into realities by blending technically feasible solutions with economic and other organizational consideration with a specified time frame. An energy audit can be simply identified or defined as a process to evaluate where a building or a plant use energy and identify opportunity to reduce consumption. There is a direct relationship to the cost of the audit, how much data will be collected and analyzed, and the number of conservation and opportunities identified. In other words, energy audit is an inspection of energy using site to find out energy losses, wastages, and efficient apparatus or processes by collection and detailed analysis of data related to energy uses and energy flow, comparison of collected results with setup standard to find out energy conservation opportunities and suggest technically feasible energy saving measures to reduce or eliminate energy losses and wastages. Energy audit helps us building owners and industries to reduce their billing cost and implementing best possible and cost effective energy saving measures by analysis of payback periods. Speaking about the need of energy audit needs to be done to identify energy saving opportunities in a facility or area with excess use of energy compared with setup standards. Energy audit is an effective tool of energy management to use energy effectively and efficiently. In another word, energy audit is a process or methodology to find out power consumption according to different areas and in various slot of time. Total connected load, maximum demand, power factor, load factor, and most importantly, it proposes economic measure to save energy and detailed comparison of cost of energy saving and investment required in terms of payback period. An energy audit is a study of a plant or facility to determine how and where energy is used and to identify methods for energy saving. Coming to the objective of energy audit, the primary objective of energy audit is to determine ways to reduce energy consumption per unit of product output or to lower operating cost. Energy audit provides a benchmark, reference point for managing energy in the organization and also provide the basic for planning a more effective use of energy throughout the organization. The other objective of an energy analysis or audits are: number 1, to identify and develop modification that will reduce the energy use and or cost of operation. 2, to acquire and analyze data and finding the energy consumption patterns. Third, to calculate the wastage pattern based on the result of the first objective. And last but not the least, to find and implement solution those are acceptable and feasible. The results should be presented in a format that will provide the information needed by an owner or an operator to decide if any or some or all of the recommended modifications should be implemented. The objective of an energy audit can vary from one plant to another plant. However, an energy audit is usually conducted to understand how energy is used within the plant and to find opportunities for improvement and energy saving. Sometimes energy audits are conducted to evaluate the effectiveness of an energy efficient project or program. One of the advantages of an energy balance is that all energy input can be quantified and balanced against all energy outputs. An energy analysis or energy audit includes many steps. The steps are: number 1, collection and analysis of historical energy use; number 2, study of the building and its operational characteristics; 3, identification of potential solution that will reduce the energy use and or cost; to perform an engineering and economic analysis of potential modification; number 5, preparation of rank ordered list of appropriate modification; and number 6, preparation of an audit report to document the analysis process and results. Coming to the aims of energy audit, in any industry, the 3 top operating expenses are often found to be energy, labor and materials. Among the 3, energy emerges as the top ranking area for cost reduction. Energy audit can help us understand more about the ways energy and fuel are used in the industry and help in identifying the areas where waste can occur and where scope for improvement exists. Energy audit is carried out with the following aims. A. Or number 1, review and upgrading of procedure for energy accounting. Number 2, review of technical efficiency of system element in sub-transmission and distribution, commonly called as ST&D system. 3, analysis of techniques for measuring the energy received, energy billed and corresponding revenue collection. 4, review of performance of equipment, meters, distribution transformer, etc. Next is segregation of technical and non-technical losses and establishment of norms for checking the consumption of various categories of consumer and overall energy balance in the circles. In general, if you see, energy audit facilitates the translation of ideas about energy conservation into reality by lending technically feasible solution with economic and other organizational consideration with a specified time frame. The form of energy audit conducted is mainly depend on the type, utility and the size of the industry. The type of energy audit to be performed depends on function and type of industry, depth to which final audit is needed and potential and magnitude of cost reduction desired. Thus, energy audit can be classified into 2 types. Number 1, preliminary audit and number 2 is detailed audit. In preliminary audit, available data are used mainly for the analysis of energy consumption performance of the plant. Preliminary audit takes a comparatively short time. Results are more common. The economic analysis is usually limited to calculation of the simple payback period. Preliminary energy audit is a relatively quick exercise to establish energy consumption in the organization, to estimate the scope for saving, identify the most likely and the easiest areas for attention, identify immediate, especially no or low cost improvements, savings. It sets a reference point. It identifies areas for more detailed study or measurement, and preliminary energy audit uses existing or easily obtained data. The second one is detailed audit measurement. The detailed audit measurement and data are usually collected and different energy systems are assessed in details. So, detailed audit needs longer time to be conducted. Results are much comprehensive and useful as they provide exact picture of the energy performance of the plant and more specific suggestion for improvements. A comprehensive audit provides a detailed energy project implementation plan for a facility since it evaluates all major energy using systems. This type of audit offers the most accurate estimate of energy saving and cost. It considers the interactive effects of all projects, accounts for the energy use of all major equipments, and it includes detailed energy cost saving calculation and project cost. In a comprehensive audit, one of the key elements is the energy balance. This is based on an inventory of energy using system, assumption of current operating condition, and calculations of energy use. This estimated use is the compared to utility bill charges. If we see the steps which are included in energy audit process are number 1, planning and preparation, number 2, review and data collection, number 3, plant surveys and system measurement, number 4, observation and review of operating processes, number 5 is data, documentation and analysis, and finally reporting of the results and recommendations. The procedure followed in detailed industrial energy audit, it includes energy audit preparation, energy audit execution, energy audit reports, and post-audit activities. The energy audit preparation, it includes audit criteria, scope of audit, selection of audit teams, audit plan, preparation of checklist, initial walkthrough, collecting energy bills, and preliminary analysis. If we talk about the second step, that is energy audit execution, it includes data inventory and measurements, analyzing energy use patterns, benchmarking and comparative analysis, identifying energy efficient potentials, and cost benefit analysis. Energy audit report include writing audit reports with recommendation, and post audit activities are preparing action plan for implementation and implementing the action plan. The audit checklist helped the auditor to conduct the work in a systematic and consistent way. Main component of the results section of the audit reports are collection of data and information, existing measurement instrument and data recorded, measurements required during the energy audit process, and parameter listed for the measurement. Coming to the energy inventory, the expanding energy deficiency and increased specialization in enhancing alternative source of energy, for example wind and nuclear energy, these are the main features of energy policy of India. An energy inventory is meant as a primary step toward the goal of energy inventions. India ranked at 81 position in overall energy self-reliance of 66% in 2014. In last 100 years, world population has enlarged by many fold. Life expectancy has been enhanced. The real per capita gross domestic product, which is a measurement of productivity of the world's individual, has risen by 600%. Lots of outstanding human, social and technological achievements are still feasible by a crucial factor, that is cheap and reliable energy. Today, world receive larger retrievable supplies of coal, natural gas and oil, even with the constant increasing rate of economic and population growth as well as increasing energy consumption than at any other period in its recorded history. This should be conveyed to new and prolonged innovation in investigation and production technology. There is every reason to assume that today's approximation of reserves are solely a fragment of what is going to be fabricated and delivered tomorrow over the world. Data gathering is the most significant activity under the process of energy auditing for measuring the utilization of energy use and energy inventory. To accomplish the energy data, effective collection of adequate and right data are needed. Few data are easily available and their collection completely diverse divisions of the plant to be audited. Collection of additional data may be done by recording and measurement. Energy audit team should be well resourced with all essential instrument for measurement. Instruments used for measurement are often portable or installed in certain equipments. Commonly used data for the measurement in the process of auditing are liquid and gas fuel flows, electrical measurement like the current intensity, voltage, power and power factor, temperatures of liquid and solid surface, pressure of fluid in pipes, furnaces or vessels, emission of exhaust gases whether it is CO2, CO, oxygen and smoke, ratio of relative humidity and brightness. The important tool used by an energy auditor for the evaluation are the load inventory and demand profile. These two tools are complementary since they both make available quantitative detail of the system that consume energy during a facility. The energy auditor must understood the exact point where energy to be consumed and about what proportion of energy is utilized by each and every system and what is the collective load of all the system together. It is helpful to understand how the overall energy load is distributed among various systems. The load inventory may be a systematic means of assembling and organizing this kind of information. It's a great tool for undertaking what-if analysis, assessment or proposed measure, for example, estimating the impact of retrofits, technological or operational change. As far as the electrical load inventory is concerned, there are two important questions which should be answered by making a list of inventory or electricity used. Number one is where and number two is how much and how fast. Magnitude of the load is a technique to prioritize for electricity saving opportunity. There are therefore distinguishing and categorizing completely different loads in a plant may be helpful as the demand is quantified. For example, how fast electricity is used by the inventory of the loads related to each and every load or group of loads which is useful for further understanding of demand profile. Waste is easily identified by the process of categorization and this frequently leads to economic saving opportunity. The best saving opportunities are considered by identification of high calculation load. In the thermal energy use inventory, identification of energy flows and energy flow chart is useful for distinguishing thermal energy flows. All vital energy flows among the facility, into the facility and all outgoing flows from the facility to the environment are represented in energy flow chart. The thermal energy outflows from a subsystem or a facility are identified and provided by checklist. Calculation for estimating energy flows can be done by using an energy flow diagram. Coming to the energy inventories and the energy balance, the implication of the energy balance principle underlying the audit is that we can quantify all energy inputs and balance them against all energy outputs. The energy flow diagram for the industrial food processing plant is a balance. The energy inflow equals the energy outflow. The Sankey diagram is a convenient graphical representation of energy balance. The Sankey diagram summarizes the energy balance for a given system indicating number 1, the magnitude of all energy inputs and outputs by the size of the arrows and the approximate sequence in which output occur along the energy flow path. To understand the supply demand scenario, first we have to understand resource and demand. As the world population is increasing day by day, natural resources are becoming limited. So, it is the need of the hour to switch on the alternative resources for meeting the demand of the population. The present estimate reserves of hydrocarbon may not provide enough amount of energy. For meeting the increasing demand, we have to move to all the resources based reserve, which can be increased use of non-fossil resources, nuclear and non-conventional energies for example. For generation of electricity, maximum hydro potential can be harnessed. and we should explore additional fossil fuel competitive import of energy. Energy, if you see, it can be classified into several types based on the criteria. For example, it can be primary and secondary energy, it can be commercial and non-commercial energy, it can be renewable and non-renewable energy. Primary energy sources are those that are either found or stored in nature. Common primary energy resources are coal, oil, natural gas and biomass, for example wood. Other primary energy sources available include nuclear energy from radioactive substances, thermal energy stored in Earth's interior and potential energy due to Earth's gravity. Primary energy sources are mostly converted in industrial utility into secondary energy sources, for example coal, oil or gas converted into steam and electricity. The energy sources that are available in the market for a definite price are known as commercial energy. By far, the most important form of commercial energy are electricity, coal and refined petroleum products. Commercial energy forms the basis of industrial, agriculture, transport and commercial development in the modern world. In the industrialized country, commercialized fuels are predominant source not only for economic production but also for many household tasks for generating general population, for example, electricity, lignite, coal, oil, natural gas, etc. Non-commercial energy are the energy sources that are not available in the commercial market for a price, and that's why they are classified as non-commercial energy. Non-commercial energy sources include fuels such as firewood, cattle dung, agriculture waste, which are traditionally gathered and not bought at a price used especially in rural household. These are also called traditional fuels. Non-commercial energy is often ignored in energy accounting. Example, firewood, agro-waste in rural area, solar energy for water heating, electricity generation, drying grains, fish, fruits, animal power for transport, thrashing, lifting power for irrigation, crushing sugarcane, wind energy for lifting power and electricity generation. Renewable energy is energy obtained from the source that are essentially inexhaustible. Examples of renewable resources include wind power, solar power, geothermal energy, tidal power and hydroelectric power. The most important features of renewable energy is that it can be harnessed without the release of harmful pollutant. Drawn renewable energy is the conventional fossil fuels such as coal, oil and gas, which are likely to deplete with time. If we talk about resources and reserve, the term reserve and resources can be used to discuss supply the various non-renewable energy sources. The concept of these two can be distinguished with the criteria. Number one, the level of certainty of their existence and the profitability of their recovery. The identification of quantity by detailed exploration is referred as reserve. With the implementation of existing technology, the reserves can be recovered economically and represent the existing quantity of energy sources. On the sure estimation of geologists, they are classified as proved, probable or possible. On the other hand, resources are a lot larger. It is referred to the amount of energy resources that exist or even known to be present, regardless of the expenditure or the technique required for recovering it. For instance, recovery of the conditional resources which are known to exist, the cost becomes too high with existing technology at a current price. If we see population and energy demand growth, we see that an intense debate is still going on about how fast the population, the economy and our energy consumption will grow in the years and decades to come. For instance, with the increase in population, energy demand also increases, although GDP per capita will decrease if GDP growth does not meet with population growth, as in case of developing nation. Population growing at an increasing pace consume more energy. Moreover, availability of energy also allows population to grow. Consumption of energy exert demands on energy resources. So, to conclude this session of the course Environmental Impact Assessment for Environmental Health, in this session we have learned about the energy audit for energy impact analysis. Energy auditing is a basic tool for energy conservation, and it is defined as a systematic exercise to identify the end use that consumes significant amount of energy. It estimates the efficiency in each of these and uses and devise method for improving efficiency and thus curbing losses and wasting energy. Energy audit provides the means to identify the area of leakage, wastage or inefficient use. In nutshell, we can say that energy audit helps in effective management of energy consumption and can lead to a significant cost and energy saving as well as increased comfort, lower maintenance cost and extended equipment life. So, it is the need of the hour to switch on to the alternative resources for meeting the demand of population. The present estimate reserve of hydrocarbon may not provide enough amount of energy. For meeting the increasing demand, we have to move to all resource based reserve which can be increased use of non-fossil resources, for example nuclear and non-conventional energies. For generation of electricity, maximum hydro potential can be harnessed, explode additional fossil fuel, competitive import of energy and use of green and clean technology for harnessing sustainable energy. Thank you.